All right, this is question number 32 on the Practice 022 ETS math test. Looking at this question, basically you've got a parabola and an ellipse, and it wants to know how do they intersect. And I just want to note that there's several possibilities. You can't just make assumptions. For instance, you could have an ellipse and a parabola that never intersect whatsoever. Or you could have an ellipse and a parabola that maybe touches at only one place that's tangent to. Or you could have an ellipse and a parabola whose vertex is somewhere inside of that ellipse so that it touches in two places. Or you could have an ellipse and let's say a parabola that goes through it like that. So the possibilities, you can't rule this out. You could have none. You could have one intersection. You could have two intersections, and you could have 1, 2, 3, 4 intersections. You couldn't have 3, but that's not even, you can't rule anything out among the answer choices that they gave you. So I've tried this a couple of different ways. One way, I put it in the calculator. This, in the first one, the parabola, y is isolated, so it's super easy to graph that in the calculator. In this one, y is not isolated, and so you have to isolate y, but because this is not a function, you have to enter it as two different functions, and I'll show you that in just a second. But by far the easiest thing to do is just know how to graph these and graph them. So I actually found that just a little bit of understanding about what a parabola and an ellipse look like on a set of axes was extremely helpful. So looking at y equals x squared minus 4, that's just a parent function of a parabola that has a vertex at -4, 0, -4. And then you just do what the parent function does. You go over 1, square that up 1, over 2, square that up 4, over 3, square that up 9. And you do the same thing. Back 1, square that. Back 2, square that. Back 3, square that. And so this is what your parabola looks like. Now your ellipse, remember that with an ellipse, anything, the vertex is based on what's in parentheses being added or subtracted to x and y. Since there's nothing there, that means that the center, this computer is just horrible. All right. It wants to jump back there for some reason. Okay, so it's at 0, 0 is the center. And then you have major and minor axes that are determined by the square root of the number underneath the x and y. So 16, when you square that underneath the x, that's 4. And so you go 4 right and 4 left in the x direction. Do the same thing with the y squared. Underneath the y squared is a 4. Square root that, that's 2. You're going to go up 2 and down 2. So this parabola looks like this. And if you look at the intersections, that's 1, 2, 3, 4 different intersections. Okay, very quickly I want to talk to you about how to isolate y in that ellipse equation. If you had x squared over 16 plus y squared over 4 equals 1. The first thing I would do is multiply everything by 16 so that I could clear those fractions out. Keep in mind that when you're wanting to put this in the calculator, it's important that you isolate y. Okay, so 16 cancels here, and that gives me x squared plus 4 goes into 16 4 times, so that's x squared plus 4 y squared is equal to 16. Okay, now then, remind yourself y. I'm isolating y, which means you move anything that's not y away from y. Okay, so 4y squared is equal to 16 minus x squared. You're going to divide by 4. And that makes y squared is equal to 16 minus x squared over 4. Now, you're going to square root both sides. But an important point of order here is that when you initiate a square root on both sides, you have to remember that it's plus or minus the result of that. So you end up with y is equal to either a positive square root of 16 minus x squared over 4. So that's one answer. And the other answer is a negative square root of 16 minus x squared over 4. So when you're putting these into your calculator, my advice is, number one, well, I'll just show you what my advice is, okay? We're going to add in a new equation. It's just going to be a regular old function, and let's do that. Come back. All right, we're going to do the parabola first, and that's x squared minus 4. X squared minus 4. I'm going to make that red. Okay. Now, when you're doing the, I'm going to have to scoop down here. Okay. When you're doing the other one, you're going to click New, and you're going to do it in two different stages. The first one is the positive one, so I'm going to do positive square root, SQRT, open parentheses, of, now you've got a numerator and a denominator. Remember, you enclose the entire numerator in parentheses, its own set, and the entire denominator. So it's going to be open parentheses, 16 minus x squared, close the numerator, divided by open parentheses 4, close the denominator, and get outside of that parentheses to close the square root. Okay, now then you have to do it separately. I'm going to do it in the same color because it's really the same thing, but to do the negative. So negative square root of, the value is, open parenthesis, 16 minus x squared, close the numerator, divided by open parenthesis 4, close the denominator, tab once outside. There we go. Okay, now if you look at this graph, you can see that right at the edges you can sort of see that they're different functions, but it's close enough so you can see how many intersections there are, and in this case you can see there are 4. So that answer, by the way, is D.